Welcome back. We're still working through this list of ways that we can have anthropogenic changes in the radiative forcing. And let's talk now about land use changes. I mean, as you change the way you're using the land, as you start watering, irrigating places that used to be desert, as you make countryside into city, whatever, as you change the way you're using the land, you can change the properties of the surface that in such ways that they change, say, the albedo of the surface of the Earth, or how much evaporation is happening off the surface of the Earth. And that has an impact on how much, radiation is being reflected or emitted or whatever from the surface of the Earth. Now, in general, when you convert natural environments into farmland, in general that increases the albedo. Most of the time, tearing up a forest and putting in a soybean field increases the albedo of the surface, although it certainly does vary a lot. I mean, taking a patch of desert near Phoenix and deciding to water it so that you can grow strawberries is going to have a different radiative impact. But overall, if we took a look planet-wide at the changes in albedo, it looks like since the Industrial Revolution, we have overall increased the albedo of the planet by the way that we use land. And then it's not a small radiative forcing. In fact, it adds up to negative 0.2 watts per square meter. That's a big change. But there are other ways in which we can change the surface that have other radiative forcings. For example, well, we know we're adding a whole bunch of aerosols to the atmosphere. And when those dusts and, when like black carbon and mineral dust and so on, if they don't wash out of the Earth's atmosphere, if they instead settle just by gravity onto the, let's say, a snowy surface, well, that changes the albedo of the surface. Okay, this snowy surface here is now experiencing a more absorption of shortwave radiation than it did before. We've decreased its albedo. So just aerosols settling onto the surface and being their dark self on what was previously a lighter surface has a radiative forcing of plus 0.1 watts per square meter. It's small, but it's real. We have to worry about it. What about changes in the sun? I mean, how about something we're not affecting? What about any possible changes in the sun? I mean, it seems like that would be a potentially very large radiative forcing on the Earth's climate. And then there certainly are radiative forcings that happen because of changes in the sun. For example, there's the sunspot cycle. There's about an 11-year cycle to how many sunspots are on the sun at any given time, and sunspots are a little bit cooler than the places around them. They emit less radiation, and so there is a change in the amount of total energy output on the sun over a course of about 11 years, but it's a cycle. The difference between the peak and the bottom, the most radiation the sun gives off and the least as part of the sunspot cycle, is about a radiative forcing of about 1 watt per square meter. That's big. I mean, that's bigger than the contribution due to methane. That's bigger than the contribution due to a lot of the other things we looked at. But keep in mind, it's a cycle. So it goes back, right? Over the course of 11 years, it averages out to no radiative forcing. Yes, at any given time. Yes, during this period, maybe this year, there's a half a watt per square meter of positive radiative forcing. But you know what? In a couple of years, there'll be a half a watt of negative radiative forcing due to changes in the sun. So this kind of cancels out. This doesn't really do anything. That being said, there actually is some evidence that there has been a net increase in the amount of solar radiation since the Industrial Revolution due to longer period changes in the sun. That if you actually, we can fairly generously say, let's say the sun has made some changes, and models suggest that it would be about 0.12 watts per square meter over the course of the last 250 years or so. Okay, we'll work with that. I mean, it's a real radiative change. There's good reason to think that the total amount of energy for the sun has increased. So if we're just going to say, since the Industrial Revolution has happened, if you add up all the trace gases and all the aerosol effects and solar changes and land use changes and so on, you get a radiative forcing of the Earth's climate of about plus 1.6 watts per square meter. Okay, in other words, if we just said all these changes here, how much are our energy balance out? We're out of energy balance by about 1.6 watts per square meter. Okay, the planet needs to warm. Now, at the present time, when you actually look, remember when we did like the energy balance with that slide from NASA, or in the book they did it, we get a energy balance of about plus 0.9 watts per square meter. In other words, at the present time, we are actually out of energy balance by about 0.9 watts per square meter. Now this is a little bit complicated because what's actually happening here says that we have already experienced some of the temperature change that we need to experience as part of achieving a new energy balance based on the changes that have happened since the Industrial Revolution. Think about that turkey in the oven, okay? At first, when you put the cold turkey into the hot oven, there's a very large energy imbalance. And there is a very large radiative forcing on the turkey. It is getting much more energy in than energy out. But if you come back an hour later, the turkey is still not as warm as the oven, but it's closer, and the energy balance is not that far off. That's kind of what's happening here. We're like the turkey that's half done, okay? We have gotten about half of the global warming that we would expect to happen based on all the radiative forcings of the aerosols and the greenhouse gases and stuff like that. Oh. In other words, we're committed to about this much more warming. If the planet has already warmed by about 1 degree Celsius, well, we're committed to about that much more warming before we reach a radiative balance. And of course, in the meantime, we'll add more greenhouse gases and keep moving the goalposts farther. But really, the big take-home message about this radiative forcings lecture is how climate change is about so much more than just greenhouse gases. It's a whole constellation of problems about changes in the sun, and methane, and land use, and ozone, and aerosols, and all kinds of black carbon, and all kinds of problems that all relate, some in positive ways, some in negative ways, to the broader problem of climate change. And you can see how that makes a huge problem for policy. Any kind of policy that's going to stabilize climate has to reduce the factors that are providing a positive radiative forcing that make the climate warmer, and we have to do things that increase the factors that have negative radiative forcing. Boy, that's complicated. Yeah, think about your representatives in Congress or, you know, whatever. You think they're going to get all this sorted out? Not without smart voters like you out there. All right, as we finish up this lecture here, let's ask a couple more questions here. Question 9. Overall, mankind's activity works to blank the albedo of the Earth's surface. Overall, has mankind increased or decreased the albedo of the Earth? Make a choice from those two options. Get a little feedback before you move on to the 10th question.